pass out some candy. Why don't you give everybody 2 rolls, since we have plenty. 1 roll is not to be eaten. Tastes good. Drop about 6 inches away.
Do we like drop it?
I actually wasn't planning to use the projector, but I may need to with the results of my coin. So just, it would be, I like this. I'm getting different experimental procedures in different groups, which is fine, but we'll think about those and talk about those. And if I'll get busy up here, I'll get a spot for you so you can record your data. All right, I've got people that know exactly what to do. They're already coming up to record the data. That's great. So you're watching the trends, you're observing. Now, you have in your mind in advance whether you think a penny is fair, right? But do you know whether candy Smarties being dropped on the plate should be fair? Interesting. I think this is everybody. What's our totals, please? Let's define success when a coin is flipped as getting ahead. And so I'll circle that one. And then in a minute, I'll rewrite this other one. And then we're going to define success over here as being on the left. Just so we're kind of talking about the same thing each time so we know. So we want to move from this concrete heads, tails, to this more abstract success, failure. Okay? And you'll see that as you move into the different distributions that are become very important for you for this class. Okay, so at the a couple of probability rules, and those are from in your book. And so, but we just put them here so you'd have them. And then, so see if that were true, if both of those rules hold for your data in both cases so far. And then you get something defined as the law of large numbers. I'll let you read those, and then we'll talk about some of that again as we move toward the end of this. Okay? So I'll let you work for a few more minutes together, and then we'll talk some more. So I'm curious what you said for number 13. I can't help but be curious on that given our results, right? So the first question, the way it's asked is, did these 2 different scenarios, so penny flip, candy drop with half of the plate, did they result in the same, did they result in different probabilities for success for these outcomes? But for the class, this is what I can sort of look at, right? They're not very different. Were they different from what you expected in this case? And so they didn't ask you that exactly, right? So your answer might have been that these are not very different from each other, but were they different from what you expected? And this is what you're going to be working toward in inference. How far is too far away from what you expect to know if candies can be dropped fairly? Can it really be 50-50? Were those pennies fair? Were your mechanisms of flipping fair? Did you do it right in this case? You know, so how far is too far away from 50-50? Do you have an intuition? Is this too far away? So if I repeated the number of repetitions of my experiment and moved that to 1,000 repetitions of my experiment of dropping that coin one time, right, then I would see that the empirical, which had been at 57%, 43% almost, that they had even, right, moved to nearly the 50-50. And so you could bring yourself back around even to this question on the very front. What did you say on the front in terms of what would you predict as the probability for heads and tails? You thought it was going to be 50-50 is what I'm hearing from most of you. So you thought it was going to be 50-50. Is that too different from 50-50? Your answer after seeing some of this might be different now, right? But think about that law of large numbers. I had 1,000 flips. In some sense, 1,000 repetitions. They have 100,000 repetitions. Well, so the probability of any event occurring has to be between 0 and 1. So that's a simple way to think.
So
So if we think of our sample space as all possible outcomes, here it was only heads or tails. So the sum of the probabilities of each of those has to add up to 100%, which is the same thing as 1, right? Phi.